Today our focus is going to be on dealing with the multiplication properties of exponents. So on this kind of a page that we're going to deal with, the properties of exponents are based on knowing, again, what the base. In a problem like this, the base would be 2, and the power or the exponent would be 3. So we have to be able to follow these and know how these work by having matching bases. So we're going to take a look at some problems today based on that. First of all, our basic properties are that when you multiply, if the bases match, so in this case our bases are A and A, so our bases match. So when you multiply, you can add the exponents. So m plus n over here is going to give us our new total. Now we're going to try this out in a couple of the problems that we have below. So if I look at number 1 on A, my base is going to be 3 in both these problems. So my base and my answer is also going to be 3. In this problem, my two powers or exponents are 5 and 4. So I would add those two together, which would give me 9. And then in this problem, in order to continue to solve it, I'm going to have to really work on, sorry, I'm just changing the size of what I'm writing with, apologize. If I do 3 to the 9th power in my calculator, I'm going to end up with 19683. So in this problem, this is going to be my final answer. The big issue for this is I have to be able to get here if I'm going to get here. Now some problems are easier. If I look at B, these have exponents of h. So h is also going to be my exponent, or my base. And then I'm going to add my exponents, which would give me 11. This is my final answer. Now I do have to be careful that on things like the one on A, that I actually go through and multiply out what I have. I can't just leave it as 3 to the 9th unless the specific directions are to leave it with one base. So let's try another problem. Oops, I have a picture there. Okay, so on this one, we have kind of an issue on number 2 because they really just want us to simplify. But sometimes there's more than one thing going on here, as we can see in A. So if I look at A, the numbers in front would be 2 and 3. Those are the coefficients. I'm actually going to pull these over to the side here. And then I'm also going to sort out my letters. So I have an n to the 5th and an n to the negative 2. So if I'm going to simplify these, 2 times 3 is going to give me 6. And then I'm going to have to take my n's and I'm actually going to have to add my exponents. So 5 and negative 2, if I were to add them together, would give me 3. So my final answer would be 6 n to the 3rd. Now I do have to be careful that I multiply all numbers out that are in some kind of exponential form. I also have to be careful that if I end up with any negative exponents, that I actually deal with them and get them into some positive exponent. So I'm going to add a 1 here down here, and let's take a look at B. First of all, I added this 1 here because anytime you have a number that doesn't have an exponent or a letter that doesn't have an exponent, we assume that it's 1. Just like we would do if we had a letter that was X and there wasn't a number in front, we would assume that there's a 1 there as well. Okay, now this is going to require this problem a little more sorting. So 5, 2, and 3 are my coefficients in front, so I'm going to sort those into a pile. And then I'm going to take my x's and sort them, and then my y's. Now my point of reference is every time I sort my letters here, there's more than one, I sort them alphabetically, because that way it makes it much easier to know if you've gotten all the things in one spot together. It also makes it easy to not overlook a number or a letter. So now if I go to this part right here, 5 times 2 is 10, times 3 would be 30. Then to solve my x values, I would just have to take my 1 and my 8 and add it together. And the y only has one exponent of 4. So my final answer is going to be 30, x to the 9th, y to the 4th. And this is going to give me my final answer. Okay, now remember again, we looked for those negative exponents if they existed, and we dealt with them. So far we haven't seen any, but they're probably going to be coming up. So let's take a look at some more here. So in this problem, this has very different directions. So first of all, read these directions here. This one says rewrite each expression using only the base once. So in these, for example, A has a base of 7, B has a base of 4, and C has a base of 6. So I want to make sure that I'm actually sorting it so that the bases appear once. Now in order to make that happen, I'm going to have to go through and add these two together. So the exponents of 3 and 2 I add together, which will be 7 to the 5th. Now normally I'd take this 7 to the 5th and I'd put it in my calculator and calculate a number out. But this says rewrite each expression using the base only once. So they actually want me to leave it like this. Now in this one, I'm actually going to take all of these exponents and add them together. So 4 plus 1 is 5, plus negative 2 would be 3. So this is going to be 4 to the 3rd. Now in this one, I'm going to add these two together. Now this is the tempting one, because this ends up being 0. And although we know that anything to the 0 power equals 1, they actually want us to stop here because, again, they wanted to rewrite it with the base only once. Okay, let's take a look at one more here. Okay, in this problem, they want us to simplify each expression, which means there's probably going to be a lot of stuff going on in these problems, and I have to be able to sort them out. So first of all, even if I just take a look at A and B, I can see a couple spots where there aren't exponents. So I'm actually going to add exponents in there. Now with this problem, my bases are all p's, and since there's only one base, I'm actually going to have to add all these exponents together. So 2 and 1 would be 3, plus 5 would be 8. So p to the 8th is going to be my final answer. Now on B, we have kind of several things going on. So coefficients in front would be 2, 3, and 4. And our letters, if we sorted them, we would have p to the 3rd, and q to the 1st, and q to the 4th. So this part, when we put them together, 2 times 3 would be 6, times another 4 would be 24. There's only one p that's there, p to the 3rd, that's going to have to go in my answer. And my q's, I'm going to actually have to add these two together. So 1 and 4 would give me 5. So this is going to be my final answer. Okay, let's see if we can take a look at maybe one more here before our time runs out. Okay, in this problem, although we haven't had a huge focus on scientific notation, we can see that there are still exponents in this problem, and we can see that there are kind of numbers. So let's sort them that way. So 3 and 7 over here. Okay, probably the easiest part is to see kind of this piece right here. I'm going to have to take that negative 3 and negative 5 and add them together and get negative 8. Now these two together are going to give me 21. But remember, if I want to actually go through and solve a problem like this, my main issue is that I want to make sure that the number that's in front where that 21 is at is going to give me a number that is between 1 and 10. And because 21 isn't, we're going to somehow want to make it so that we can put a decimal and create a number that is, again, between 1, and 10. Now remember in this one, if I do this, that's actually taking my number and making it smaller. This is already pretty small, so we're going to be able to take one of those away. And then this is going to be our final answer.